Hello everyone, welcome to my channel Vidyarthini's Academy of Computer Science, Learn with Passion. In today's video lecture, we'll be learning about process scheduling. In my previous session, we learned about process state and process control block. In this session, we'll be studying about process scheduling, which is the continuation of that. And before we get started, if you like my video lectures, please do like, share and subscribe to my channel, and don't forget to press the bell icon. Let's get started. Process scheduling. First, let us look at the definition of process scheduling. The process scheduling is the activity of process manager that handles the removal of running process from the CPU and a selection of another process on the base of particular strategy. The work of the process manager is to remove the process which has completed the use of CPU from the CPU and select another process which is in need of the processor and based upon the particular strategy. It uses certain strategies, for example, the strategy might be first come first serve or shortest job first, like that. All that we'll be learning in the upcoming chapters. For now, you have to know the definition, that is, it is being done by the process manager, and what he does the work of removing the already running process from the CPU and selecting another process based upon certain strategies. And process scheduling is an essential part of multi-programming operating system. Why do we need process scheduling? It's because there will be multiple processes which are in need of the central processing unit, that is the CPU. And the main aim is to not let the CPU idle. That is, a CPU must be always given some work, that is, some process or the other should be always using the CPU. Okay. To reduce the idle time, we are using this process scheduling, and this is very important when it comes to multi-programming operating system. Such operating system allow more than one process to be loaded into the executable memory at a time, and the loaded process shares the CPU using the time multiplexing. That is, there will be many processes using the CPU without wasting the CPU's time. Okay, all right. Next is a process scheduling queue. OS maintains all process control blocks in process scheduling queue. PCBs, we learned about PCBs in our previous session, right? So OS maintains all PCBs in a process scheduling queue. That is, the OS maintains a separate queue for each of the process state, and PCBs of processes that are having the same state are placed in same queue. That is, we learned about a process state, right? Ready, waiting, running, terminated. So these are the states of the process, and PCBs, each process will have its own PCB, and the process which are of the same state, for example, either it is running or waiting. So where all the process which are of the state ready will be kept in the ready queue. All the process which are of the state waiting will be kept in the waiting queue. So that is what they say in the second point. OS maintains a separate queue for each of the process state, and PCBs of all processes in the same state, same execution state, are placed in the same queue. Which are having the same state are kept in the same queue, and when the state of the process is changed, say for example from ready to waiting, when it is changed, then the PCB is unlinked from the current queue and moved to the new state queue. That is what they are saying. So it collects all the related process which are having the same state and place in one particular queue, and when the state of the process changes, the PCB of that particular process is unlinked from that current queue and it is moved to the next queue. All right. Next, the operating system maintains the following important process scheduling queues. What are the queues that OS maintains? The job queue, ready queue and device queue. What is job queue? All the processes are kept in this job queue. That is, the queue, this queue keeps all the processes in the system. Whatever the processes that are there in that system, all the process will be kept in the job queue. And ready queue. This queue keeps a set of all processes residing in the main memory that are ready and waiting for execution, waiting to execute. So all the processes which are ready to execute and it is waiting to be executed will be kept in this ready queue. A new process is always put in this queue. So when a new process comes, it is ready to execute and it is always put in this ready queue. Device queue. What is device queue? The process which are blocked due to the unavailability of IO devices constitute this queue. Say for example, IO device, a process has to get executed because of the process has to be executed, but it is waiting just because of unavailability of IO device. That process will be kept in device queue. IO device in the sense it can be either printer, scanner, or anything. So the process which is waiting just because of unavailability of IO devices will be kept in this device queue. Alright, we'll see the pictorial representation. Job queue, ready queue. A process comes and it will be in this ready queue and it will be using the CPU, and just because of IO device unavailability, it will be waiting in this IO waiting queue and then IO queue, and it will again, when it gets its chance, it will go to the ready queue and then it will be executed by the CPU, and once the work is done, it will get exited. So this is the diagrammatic representation of process scheduling queue. Okay. The OS can use different policies to manage each queue. That is, the policy might be like first in, first out, FIFO, or round robin, or priority, etc. And the OS scheduler is the one which determines how to move processes between the ready and the running queues, which can only have one entry per processor core on the system. And in the above diagram, this OS scheduler is being merged along with the CPU. Alright. Okay, the next topic is two-state process model. In this two-state process model, there are only two states, either running or not running a process, not running a state. A two-state process model refers to running and non-running states which are described below. Okay, this is the diagrammatic representation of a two-state process model. Here there are only two states, either it is not running or running. When the process enters, it will be in a not running state, then it will be going to the running state. Okay, the process can be in one of the two states, either it is running or not running, and when the OS creates a new process, it enters into the not running state. First it will be not running, and after that the process exits and it is known to the OS and waits for the opportunity to run. So when one process is created, it just goes and according to this two-state process model, first when the process is created, it is in the not running state, and when it is known by the operating system, it just waits for giving an opportunity for that process, and from time to time the currently running process will be interrupted, and the dispatcher process, there is something called as dispatcher process which we'll be learning again, and will be selecting a new process to run. From time to time the currently running process will always be interrupted, that is saying that there is one new process has come which has to use the CPU, so it will be interrupting the currently running process, and the dispatcher process will select the new process to run in the CPU. The new process will be moved to running state, and the former one, the one already which is running in the CPU, will be moved to the not running state. Okay, so the new process will be now in this running state, and the one which is already running in the CPU will be moved again to the not running state. So that is all about two-state process model. All right. Next is the schedulers. Schedulers are special system software which handles process scheduling in various ways. That is, in the lifetime of a process, that is process creation till it is exited from the CPU, it undergoes different kinds of scheduling queues, and the OS also has to select a process based upon the purpose and what are the processes it is undergoing, and it also should select a process. And for this purpose we are using schedulers, and that is, the scheduler's main task is to select the job to be submitted into the system and decide which process to run. Okay, there are three types of schedulers: long-term schedulers, short-term scheduler, and medium-term scheduler. First we will be learning about long-term scheduler. Long-term scheduler is also called as job schedulers. Long-term schedulers determines which programs are admitted to the system for processing, and it selects processes from the queue and loads into the memory for execution. The long-term scheduler will be selecting the process from the queue and loads into the memory. The process loads into the memory for CPU scheduling. The primary objective, why do we use this long-term scheduler, is to provide a balanced mix of job such as IO bound and processor bound. So what is IO bound and processor bound? IO bound in the sense it is always giving importance for IO operation and not giving importance for the processor. That is minimum use of processor and more use of the IO operation. Whereas processor bound in the sense it is that is, more calculations are getting done, that is more operations are done in the CPU, and there are the IO queues are always empty. So there must be a balance between IO operation as well as the processor, that is CPU operations. So that is what they say, and for that purpose we are using this long-term schedulers. It also controls the degree of multiprogramming. Degree of multiprogramming in the sense what it is: if the degree of multiprogramming is stable, then the average rate of process creation must be equal to the average dispatcher rate of process leaving the system. So new process coming in and the old process going out, that must be equal. That work is being maintained by this long-term scheduler. Okay. On some system, the long-term schedulers may not be available, or it will be minimum. In some systems, in the sense, for example, in time-sharing operating system, it has no long-term schedulers. So time-sharing operating system will be using medium-term scheduler. We will be seeing in under medium-term schedulers, we will be seeing that. And when a process changes the state from new to ready state, then there is no long-term schedulers. Okay. The next is short-term schedulers. Short-term scheduler is also called as CPU scheduler. Its main objective is to increase system performance in accordance with the chosen set of criteria, and it is the change of ready state to running state of a process. And this short-term scheduler works between the ready state to the running state of a process. CPU scheduler selects a process among the set of processes that are ready to execute and allocate the CPU to one of them. So it selects among the processes which are ready to be executed, and it allocates the CPU to one of them. And short-term schedulers, also known as dispatchers, so this is what is called as dispatcher, and makes the decision of which process to execute next. Short-term schedulers are faster than long-term schedulers because their work is between the ready process and to allocate the CPU. That is why they are called as CPU schedulers. Okay. Next is the medium-term scheduler. A medium-term scheduler is a part of swapping. It removes the process from the memory. It reduces the degree of multiprogramming. The medium-term scheduler is in charge for handling the swapped out process. That is, we said time sharing operating system will be using medium term scheduler, right? That is, in time sharing operating system, the CPU will be allocated for a particular process for a particular set of time. After the time elapses, the process has to be swapped out of the memory, and this medium term scheduler will be doing that swapping out process. Alright, the running process may become suspended if it makes a IO request. So what happens? The suspended process cannot make any progress towards completion. So in this condition, it has to be removed. To remove the process from the memory and make space for other processes, the suspended process is moved to the secondary storage. This process is what we call it as swapping, and the process is said to be swapped out or rolled out. So the process is swapped out or rolled out. Swapping may be necessary to improve the process mix. That's all about the three types of schedulers. Now we will see the comparison among the schedulers. Long-term scheduler, it is the job scheduler. Short-term scheduler is the CPU scheduler, and medium-term scheduler is the process swapping scheduler. And the speed is less than short-term scheduler, whereas speed is in short-term scheduler, speed is fastest. And medium term scheduler, the speed is in between both short and long term. And long term scheduler, it controls the degree of multi-programming. It provides lesser control. The short term scheduler, it provides lesser control over degree of multi-programming. Whereas medium term scheduler, it reduces the degree of multi-programming. So higher control is under long term scheduler, will have the higher degree of control over the multi-programming, whereas medium term scheduler, it reduces the degree of multi-programming. Long term scheduler, it is almost absent or minimum in times of time sharing operating system. It is also minimum. The short term scheduler is also minimum in time sharing operating system, whereas medium term scheduler, it is a part of time sharing operating system. And in long term scheduler, it selects processes from pools and loads them into memory for execution. Whereas short-term scheduler, it selects the processes which are ready to execute. So in a long-term scheduler, it handles from end to end, whereas the short-term scheduler will select only the process which are ready and it just executes. Whereas in medium term, it can reintroduce the process into memory and and execution can be continued. So this is the comparative study about the three types of schedulers. Next is the context switching. Context switching is the mechanism to store and restore the state or context of a CPU in process control block so that the process execution can be resumed from the same point at a later time. So when a process is getting executed and when the CPU moves to the next process, the state of the process 1 is stored in its PCB, so that when the process 1 comes back to the CPU, it can resume from the place where it left the CPU. So that is what is context switching. Using this technique, the context switching enable multiple processes to share a single CPU. So using this context switching technique, multiple processes can share the CPU. Context switching is an essential part of multitasking operating system feature. All right. Next, when the scheduler switches the CPU from executing one process to execute another, the state from the current running process is stored into the process control block. So when a CPU is switching from one process to other, the state of the process 1 is stored in the PCB 1 and it just moves to the process 2. And after this, the state of the process to run next is loaded from its own PCB. So PCB 2, the state of the PCB 2 is loaded from its own PCB and it has been executed by the CPU. That is, the state of the process to run next is loaded from its own PCB and used to set the PC register, etc. And at that point, the second process can start executing. So this is the diagrammatic representation of the contact switching, that is when CPU will be having process 1, and when it moves to the process 2, the state of process 1 will be saved in its own PCB, and the state of the process 2 will be loaded to the CPU, and when the work of the process 2 is finished, the state of the process 2 will be saved in the PCB 2, and it will be restoring the state of the process 1 to execute the process 1. Alright. So contact switches are computationally insensitive since registers and memory state must be saved and restored. To avoid the amount of contact switching, some hardware system employs 2 or more set of processor register, and when the process is switched, the following information is stored for later use. What are they? They are PC, we saw, right? Program counter, scheduling information, base and limit register value, currently used register, changed state, IO state information, accounting information. These are the informations which are to be saved and restored. Okay, so that's all about process scheduling. Next topic that I will be covering is cooperating process. Thank you. And if you like my video lecture, please do like, share and subscribe to my channel, and don't forget to press the bell icon. Thank you so much.